Hey guys, welcome to another video. So today we'll continue on with the nice question series where the question from today comes from the advanced syllabus. It's a nice little question from the last question in the Sydney Boys 2022 trial paper. It's a question to do with series mixed with trig. Generally, I found it quite not as easy as I thought it'd be as part of the advanced syllabus, but it's the last question, so give it a bit of respect. So before I go on, if you haven't already done so, please like the video, subscribe to the channel, and tell your friends. So let's get started. So this question from Sydney Boys, last question, so let's go through it. Now, there's three parts to the question. I think in total it's worth 7 marks. So in the triangle ABC, BC is perpendicular to AC, okay, the right angle down there. Side B, it's basically it's describing this triangle, right? So about triangle has A, B, and C as the sides, and the center is over there, okay? And everything's right angle. So one thing that isn't part of the diagram, that's right angle there, right? Yep. All right. Explain why X equals to A, B on C. Now, I think it's fair to say that there's a few ways to do this. You can do this with trigonometry, or you can do this with similar triangles. Both are good, but I think I'll use trig. Now, next question is a nice one. So form lines. So basically, they keep drawing sort of these arcs, right? New quadrant is constructed, and the process is repeated indefinitely. So then prove this. Prove that the limiting sum of all areas is that 4 marks, right? Lots of marks there. And last but not least, once you've done that, hence show that guy there for 1 mark. Okay, piece of cake. All right, shall we? So explain why X equal to this for 2 marks. Now, the way I'm going to attack this question is, so you can sort of see there's 2 right angle triangles, right? There's one that is there. Draw that a bit better. One there, right? And then there's one sort of outside, right? Yeah. Now, so if I call this angle here theta, yeah, I can use theta in the pink triangle and use theta in the blue triangle to sort of get an expression for, say, sine theta, and then equate them, right? So I'll start with the pink triangle. So part A, yeah. So firstly, maybe let angle CAB equal to theta, right? So then in the pink triangle, right, where this is now theta, I sort of have X over here, right, and B down here, and the right angle is up here, so I can go sine theta is opposite on hypotenuse. That's the expression. And then for the blue bigger triangle there, this is B, this is theta, and this is C. Wait, that's not what they want me to connect. Oh, shouldn't have done that. They do want C there, but they want A in there, right? And which makes sense because I need sine, yeah? And then sine theta in this case is A on C. Equate these two, right? Yeah, once they're equal, sort of equate them. Therefore, X on B equals to A on C, X equals to AB on C, which is exactly what they want. Nothing too hard about that. Now you can use similar triangles as well, but let's move on now. Just gonna move this over here. Zoom in. Right, the next one now. Show that the limiting sum of the areas, right? So it might be worthwhile. So where are my areas? There's a semicircle there. Sorry, a quarter of a circle there. Quarter of a circle there. It goes on indefinitely. Now, it's important to realize it's a quarter of a circle, right? So if I was to firstly gather an expression for the limiting sum, so for part B, so let A equal to limiting sum of areas, right? So therefore, A in this case now will be a quarter of this circle. Now, the radius for this circle, right? R is X. So, sorry, I just drew all over it. So this guy's R, right? These are all the radiuses, right? So it'll be a quarter pi R squared plus, so that's the first one, then a quarter pi x1 squared plus a quarter pi x2 squared, and so on and so forth. Right, so if I had to factorize this, it'll be pi on 4 times x squared plus x1 squared plus x2 squared, and so on. Right? That's the expression for the limiting sum. Now, I need to prove that that expression equals to that blue one, right? So I need some sort of connection. So this is how we're going to do it, right? So once again, basically, I'm just going to introduce, once again, theta as this angle here, and basically just use trigonometry and get expressions for sine theta, right? So I'll start with, now I'll draw pink first, right? I'll do pink first, right? So from the pink, just like above, yeah, that's right angle there. This is x, right? And this is b right now, right? And this is theta. So just like above, I got sine theta equal to x on b. Well, just like above. Now, similarly, can you see if I drew a right angle triangle here, right? Actually, you know, I'll use a different color. I use blue. Yeah? That one there. Now, the important thing is this side here is x1. Now, what's this side here? Because the whole side is b. Now, it's important for you to sort of see, right, that the radius for this guy here, that's x. That's also equal to the radius here, right? That's x from here to here. Right, this is x. So therefore, this length here must be b minus x, right? Yeah, so then you go for the blue triangle, whoops, blue triangle, so slightly smaller triangle. I've got b minus x over here, I've got theta over here, and I've got x1 over here, right? So then sine theta equals the opposite on hypotenuse. Yeah, and then once again, I'm going to equate them because I want an expression, right? I want an expression for x1. Yeah, because this is the game, right? I'm going to try to substitute values of x, x1, x2 all into there to see if I can get an expression that would decrease it, right? Now, you're probably thinking, wait a second, if I substitute everything with x, there's going to be x, but I know that the thing I want to prove has no x's, which is where I'm going to use part A, x equals to AB on C to help me solve it later. But for now, check this out, right? Yeah. So I'm going to equate them where I go x, therefore x on b equals to x1 on b minus x, right? Now, I want to make x1 the subject, so therefore x1 equals to x multiplied by b minus x on b. And that's not really pretty, but check this out, right? Equals to x times, that's like 1 minus x on b. And then for my x, right? I know that from part A, it's AB on C. Yeah. I've got no more vertical space. That's a problem. So you know what? Can I? Oh yeah, the hips. Borrow some upstairs. Beautiful. Okay. Let's see if I can simplify this fraction down, right? So I guess technically right now, is it a good idea? Yeah, it might be a good idea to substitute this guy into this value of x as well. I was just going to do this one, but let's do it. So it'll be AB on C outside of 1 minus AB on C on B. And it looks like B's cancel out. And you get, therefore, x1 equals to AB on C multiplied by 1 minus AC. Now what you're going to realize is that x1 equals to this expression, right? And then you can derive an expression for x2 just to see the pattern, and thereafter develop your limiting sum, right? So let me do one more. And for the last one, they don't have it on the diagram, but let's say this triangle here, where this radius is x2, yeah, where I know if that's x2, right, using the two radii once again, right? So you know what? I'm gonna see if I can. Let me go to a new page, right? Let me go to a new page, because then I can remove all this junk. Whoops, I accidentally removed the question as well. Yeah, remove all this chunk. I'm gonna remove everything here. Yeah, just for me to develop an expression for x2, and then I'll connect it with the past. So what am I trying to do, right? Actually, you know what? I'll bring this back. So that's actually where I'm going with all this, right? Yeah. So I need an expression for x2. Now, where's x2 on the diagram? x2 is over here. Let me zoom right in so I can actually show you where I'm looking at. Okay. So that line there, that's x2, which means this guy here, right? I need this side here. Now I know previously, right? I knew that this guy is x. Yeah, from here to here, that's x, right? And I know that from here to here, that's x1, which makes the green one, yeah, x, so that's b, right? B is the whole line minus x minus x1, right? And then like before, if I sort of said, let that be theta over here, I can use sine, yeah, I can use trigonometry to help me find the expression. So using trigonometry, if I scroll over a bit, sine theta equals to x2 all over b minus x minus x1, right? And I'm going to set that equal to, now I've got an expression that sine theta equals to x over b, right? Now, what do I want? I want to make x2 the subject. So therefore, x2 equals to x, yeah, multiplied by b minus x1 all over b. Yeah. I'm going to leave the x outside by itself, but in the bracket, I'm going to divide, that becomes 1 minus, now I'm going to add these, right? So you sort of get like x plus x1 over b, right? Split the fraction. Now, I know that from the previous part, x1, let's see, what was it? I got x1 to be this guy, right? So I'm going to sub that in along with x. So I know that x is the same as AB on C, and I know that x1 is the same as AB on C times 1 minus AC, right? If you look at the last part, right, it's the same thing. So sub that in. Now I've still got an x there, so AB on C as well. So maybe I'll simultaneously flow that into there as well. I'm going to show you something though. Comes AB on C plus AB on C times 1 minus C all over B. Yeah, I'm just going to clean some stuff up. So again, no space. Wow. Okay. Oh, that's because I started halfway through the page. So bring this right up. Okay. So I'm focusing here, right? I'm going to clean up this algebra here, right? Where you go AB on C, 1 minus B. I'm going to factorize AB out. Oh, sorry, AB on C out. It becomes what? 2 minus A on C. Now at this point, that guy cancels out, right? So then you get AB on C, 1 minus, now what's that? 2A on C plus A on C squared. Now, I wonder if you can see the perfect square there, right? Yeah, that's where I'm going with this, because if that's a perfect square, I get 1 minus A on C all squared. Now, what's that telling me, right? It's telling me that if X equals to AB on C, if X1 equals to AB on C times 1 minus AC, and X2 equals to AB on C, 1 minus A on C squared, I can sort of see that's a GP developing, right? And I know it's got a limiting sum because in that triangle there, C is a hypotenuse and A is one of the sides. So C is always bigger than A. So this fraction is always going to go smaller, right? So basically 1 minus this guy is always going to be a decreasing ratio, which gives me a limiting sum. So therefore, right, from this, right? This will give me a GP, so a limiting sum GP, right? Yeah, where A is, sorry, in terms of the formula, right, which is A1 minus R, A, right, is equal to AB on C, and R is equal to 1 minus A on C, right? So let's get that expression up here, right? Yeah, because that's going to be my, I'm hoping, right, that that's going to be my answer. So let's see. So coming back to this guy up here, right? So if I said to you x1 squared, oh, this is a squared, right? Sorry. They want squared, right? They want squared versions of this, right? Because I'm looking at the bracket here, right? That's a that right now I'm just trying to do this part, right? Yeah. Whereas x squared, so I'm gonna have to square this guy. I'm gonna have to square this guy. Square this guy. So the first term is that guy squared, and the second is that guy squared, right? Yeah. So let's put it all together from here. Yeah. It's not easy, this question, right? It's just got multiple parts, but the first and most important part that you need to do is develop an expression for x squared plus x1 squared, which I have downstairs, right? So if I said to you, this guy here is the sum to infinity, right? Which is downstairs. So let's do that. So it'll be like, therefore, area equals to pi on 4 multiplied by A, what's A? A on B, sorry, AB on C squared. AB on C squared. And then 1 minus the ratio, which was 1 minus A on C squared. Yeah, let me have a quick look. Yep, okay. Now, given that, that looks to be the algebra, right? So I need this now to, let's have a quick look at the thing I need to prove. Yeah, feels like it's got all the elements. So just now, I just need to clean this up, right? So let's do that. So I'm just gonna freestyle and clean this up. So that becomes what, pi 4 multiplied by A squared, B squared, C squared, and on the bottom there looks like it's 1 minus 2A on C plus A squared on C squared. Now, looks like the ones go away. So then pi on 4 multiplied by the B squared on C squared. That becomes, you know, I'll factorize A on C out, because then that becomes 2. You know what? I'll factorize A on C. I'm going to force factorize A on C squared out. Because then that becomes, now do I want 2 or 2A? So look, 2C. 2C. Oh yeah, no, that makes sense. Because if I factorize that out there, that becomes 2C plus A, right? And then C squared goes away, right? And one of the A's go away. So therefore, A equals to AB. So pi AB on top. And the bottom, is there a 4? Don't remember seeing a 4. Yes, there is 4 times 2A. Minus, because that's a minus. Apologies. Yeah, because that one's minus times positives and minus there. Yeah. Over 2C, no, 4. 2C, let's say. Nice. Guys, that was a bit intense, but let me play that back again, right? So basically, to do this question, it was really important for you to develop this line, right? Right? Which basically means the sum of all the quadrants is a limiting sum as such. And then it was up to you to find the value of this limiting sum part, right? By developing expressions for x, for x1, x2, which is what we did, right? And we basically concluded that x squared, x1 all squared, x2 all squared sort of looked like that. Actually, I should put a little squared on these, right? And then once you develop that, sub it into, it becomes a limiting sum where the a is x squared, right, which is ab on c squared, and the ratio is 1 minus a on c all squared, and then it's just algebra. Yeah. Now, last piece of the puzzle, let me copy down these parts, delete this so I can have space. Let's have a look. Last piece says, can you please, for 1 mark, show that that is less than that? Okay. Now, inequality here is important, right? It's the tell, right? So basically, right, this is telling me I can see if they ask me to do some sort of error, because I was wondering this before, right? You sort of got like, the question sort of has like these quadrants, right? You can sort of see these quadrants, but you can sort of see the quadrants compared to the area of the full triangle, there's a bit missing here, right? There's all these sort of uncovered areas. So if I was to compare the area of the whole triangle compared to the quadrants, the area of the triangle is bigger, right? So I can actually write something like, for part C, area of triangle ABC is greater than the area of limiting sum, which I let to be A, right? So I can use A here, right? Now, maybe what I'll do, because it's less than, maybe I'll write it backwards, right? Just so I don't have to flip it. So I'll go, the area of all the quadrants is smaller than the area of a triangle, right? And so therefore, what I'm going to do using, I've proven this guy to be what A is, so I'll sub that in. So it'll be like pi AB squared all over 4 2c minus A. It's going to be less than. Now, area of that triangle is easy. It's just a half times base times height. Right, given that then, really simple, looks like A goes away, one of the B's go away, 2 goes away to 2, and I think that all they did is multiply this guy up, right, and then you're done, right? And because C is bigger than A, 2C minus A has to be positive, right? So therefore, pi on 2 is less than 2C minus 4, sorry. And bring this guy down as well. Sorry, I forgot about that B. Bring him down. So you sort of go, it's less than 2C minus A 1B. Is that okay? So, guys, this question was nice, right? It wasn't, given that it's series and trig, those topics by itself, aren't generally hard, but together as a final question, Sydney boys, was a bit intense. Hopefully that was okay. Once again, if you like that, please like the video, subscribe to the channel, and tell your friends. Thank you very much. See you guys later.